Hello everyone and welcome to another video. In this video, we will discuss SSL certificates. SSL stands for Secure Socket Layer. SSL certificate is a digital certificate that authenticates a website's identity and enables encrypted communication between the web server and the browser, ensuring secure data transmission. Now, in order to understand SSL in a better way, let's understand how internet works. Suppose we have a user that needs to connect to the internet. Now say this is our user and this is the internet that he wants to be connected to. Now the user will send a GET request to the internet and the internet will send a response for that GET request. This is how connection is established between the internet and the user. This is the back and forth operation. But the problem comes when a hacker comes in between the user and the internet and sniffs all the data. Now, suppose this is our hacker and he comes between the user and the internet. Now, all the requests that the user wants to send to the internet will be intercepted by this hacker and they will pass through this hacker. And this hacker also can create a copy of that data or the request or the response that the user need to send to the internet, or the internet is giving response to the user. This is where encryption comes into the picture. We just delete these connections first. Suppose our user have a data, let me put it here, and it is our data, and he needs to send this data to the internet. But the problem is there is a hacker sitting in between the user and the internet. Now, if he just tries to send this data, let me just establish a connection between all these three. Now, if our user just tries to send this data will flow through the hacker, and the hacker might keep a copy of this data and send the data to the internet or the server. Now, this can be very dangerous at some point where the data is very sensitive. For example, user is sending their credentials like username or password to the internet in order to log in into any website. Now, these can be sniffed or intercepted by the hacker and he can read that and manipulate that. These type of attacks are known as man in the middle attack, MITM, in which a hacker sits between the user and the internet. Now, this is where encryption is into the picture. Now, let me just delete this data. The data is available with the user only. Now, if the user tries to encrypt the data, encryption means changing your data in a way that nobody else can read it. Now, let us take an example. We have 1, 2, 3, 4, and we use an encryption that will just reverse these numbers, and instead of 1, 2, 3, 4, this will become 4, 3, 2, 1. Now, this 4, 3, 2, 1 will make no sense to anyone who has intercepted it. But the user can use decryption that will create this 4, 3, 2, 1 to 1, 2, 3, 4 again and use that data as it is. This is known as encryption. Now, what will happen? User will have a key. Let me put a key here. User will have a key that will encrypt this data. Now, once this key is used to encrypt this data will be encrypted, and even if this data is passed through the hacker and hacker keeps a copy of it, this data will have no value because that data is encrypted. Let me just put that encrypted data as read. Uh, yeah, got it. Now this same data will be available with the server too. Now this key is the only way by which this data can be encrypted or decrypted. This type of encryption is called symmetric encryption, in which same key is used to encrypt or decrypt the data. Now the problem with symmetric encryption is this key is supposed to be with the server too. Now if our user tries to send this key via that path, the hacker can intercept that key and keep a copy and then send the key to the server. Here, the hacker can decrypt the data and read all the sensitive information. To solve this problem, we have another type of encryption, that is asymmetric encryption. In this encryption, there are two keys present. Now, let me just delete this key first, and the data is with user only, not with the hacker. Now in the asymmetric encryption, there are two keys present. For example, we have these two keys. Now these keys will be present with the server. And one more thing, one will be the private key and another will be the public key. Now this private key is supposed to be with the server and only the server. And this public key can be with anyone. This can only be used for the encryption of data, and this private key can only be used to decrypt the data. Now, if a user wants to send the data to the server without the hacker intercepting that, what server will do is, server will send a copy of its public key to the user. Even if the path is same and the hacker creates a copy of this, there is no value of this key to the hacker, and the key will be with the user too. Now, what user will do is, user will encrypt its data. Now, this encrypted data flows through the same path. The hacker keeps a copy of that data, and that data is sent to the server. Now, the server, with the help of its private key, will decrypt the data and read that. Let me put it as white here. This can be a very efficient way in which data can be sent to the server without the hacker intercepting it or manipulating it. But there is one more problem here. The hacker can act as a server and send its public key to the user. Let's have some visuals so that we can understand it in a better way. This is for the server. We don't need this here. Now, for example, there is another key, this and this. Let me put it as public key, that is read, and there is a private key for the hacker. Now this server is also having the public and private key, and the hacker is also having the public and private key. Now what will happen is, this hacker will act as a server for this user, and this hacker will also act as the user for this server. Now what will happen is, when user will try to establish a connection between him and the server, the hacker will come into the way, that is MITM, and it will ask the server for its public key. Now this public key comes to the hacker. Now the public key of the hacker will be sent to the user, pretending to be the public key of the server that is with the hacker. By the user will encrypt its data and send it to the server in a hope that this key will protect his data. Now this data is copied by the hacker, and using its private key, the hacker's private key, this data can be again decrypted. Let's say decrypted data is green. The decrypted data is again encrypted with the help of public key of the server and again sent to the server, which is then decrypted by the private key of the server. Now the data is with hacker 2. Again, there is a problem. To solve this problem, there should be someone to authenticate who can send their public key to the user, right? To solve this, we have something called certificates. Now these certificates are provided by an organization. This certificate will hold a signature. This signature will always be equal to public key of server plus public key of certificate provider. When a user will try to establish, let us say now these connections are not established yet, and this public key is still with the hacker and the public key of the server is still with the server only, and the data is not transmitted yet. Data is here only, and data is, there is no changes to the data right now. Okay. Now, when the user tries to establish connection between himself and the servers will send its public key and the certificate together to the user, stating that I am a valid server. Now, the certificate is given to the server when it is created. It just authenticates its identity and it says there can be a secured encrypted communication established between you and the server. Now, if a hacker comes in between server and the user and tries to give his public key, there is no certificate attached to it. Therefore, this key is not accepted. It is not an SSL certificate. This is how SSL certificate works. Thanks for watching this video. If you liked this video, please like, share and subscribe to the channel.